Hi, stat students. The few that we had skipped in class, we're not going to do all the ones that we'd skipped in class, but I do want to get a couple more done just to give you a few more examples. Starting with example 3, this is in your notes on page 24. It says studies on automobile safety suggest that stopping distances follow an approximately normal distribution. So this is how I know I'm not using binomial, geometric, whatever, telling you specifically we're about to use the normal distribution. For one model of a car traveling at 62 miles per hour, the average stopping distance is 155 feet with a standard deviation of 3 feet. Danielle is driving one of these cars at that speed when she spots a wreck 160 feet in front of her and needs to make an emergency stop. About what % of cars of this model when going this speed would be able to make an emergency stop in less than 160 feet? And is Danielle likely to stop safely? So the steps that we said that we need to follow is first to draw a normal distribution. So the first thing I'm sketching out is my normal distribution. Now we do have two options. Now first of all, that is a very crooked normal distribution. It really doesn't matter as long as you label the same two things. You always need to label your mean located in the center and at least one standard deviation, and the easiest way is just to say that, oh, this width to that inflection point has this standard deviation. Now, you could draw the one specific to this problem, or you could draw the standard normal distribution. It won't matter. I will show you both ways for this problem, and then I'll remind you which way I default to. So this one I'm going to go ahead and think of in terms of z-scores, which means my mean is a 0 and the standard deviation is a 1. This is my standard normal distribution. So it's been standardized into my z-scores. And it's talking about stopping in less than 160 feet. So step 1 I've completed with drawing my normal distribution. Then we standardize the boundary value to use the table or technology, which means I'm trying to figure out stopping in less than 160 feet. That boundary of 160 feet is what I will be standardizing. So I will take my value, I will subtract the mean, the original mean, not the 0, and then divide by the original standard deviation to calculate my z-score. So this is going to be 5 divided by 3. I'm going to have about 1.67. So then I'm going to label that on my picture. This is the z-score that I want. So I'm trying to find the probability that I'm going to stop in an amount less than this. So this is my boundary. Most of the cars are going to be below this because I know it's over half. I just want to know what % will be doing this. So I'm calculating the probability of getting a z-score that is less than 1.67. You could use your table of standard normal values because we have our standardized score, or we could just use our normal CDF function. When we do this, we do still need to state what is our lower boundary, and because it's just going forever to the left, I'm just going to say negative 1,000. We're going to say our upper boundary, so it continues all of this all the way up until it hits 1.67, and that is a standardized score, so the mean, I'm just going to write the word mean, is being used as a 0, and my standard deviation is a 1. So I'm going to go to my calculator and do that, and I was going to just show you that calculation. Let's see if I can get this to be viewable. Okay, so I'm still going to second vars, and again this only works for TI 83s and 84s. Everybody else, it should be the same location that you found your other distributions, the geometric and the binomial. It's just at the top for my menu. So I'm going to leave it like this. I could change it to negative 1,000. As long as it's a very negative number, it's going to be just fine. Sorry for all the shaking camera here. And then I'm going to put in 1.67. And because mine defaults to the standard normal, I don't need to change that. My mean is a 0. My standard deviation is a 1. I can go ahead and calculate it. So 0.9525. Oops. So it's about 0.9525. Now again, that is one possible way to answer it, and it is 100% correct. However, it is not the only way. I'm not gonna lie, that's not the way I usually do the problem. I usually do not standardize my scores. I instead usually think of it with a specific scenario. So I still will be drawing a normal distribution, but this one will not be the standard normal distribution. This is this normal distribution specifically for this data. So the mean is 155. This standard deviation is a 3. So these values don't represent z-scores. These represent, what is it, stopping distances? Yeah, I'm gonna call it that. So this is stopping distances in feet. So I don't need to go through the steps of standardizing. I'm just gonna go ahead and start considering the probability that this specific x value is less than 160 feet. So I was doing a z-score being less than something, but I don't have it standardized, so it's an x value. But it's still a normally distributed shape, so I still use normal CDF, and I still have to state all my boundaries. Still gonna use something very, very, very negative. The upper will be, I forgot something. I should have gone ahead and labeled what I'm actually finding. I needed to shade on my curve, I forgot. So 160 would be to the right of 155. And then I'm still finding the probability of being below that. So the upper is 160 with a mean of 155 and my standard deviation of 3. So let's find that approximate value. I'm going to go back to my calculator. So still normal CDF. I'm still going to leave my lower boundary the same, but this time it's the 155. Wait, not 155, 160. Sorry, I'm trying to balance and type at the same time. The mean was the 155, and the standard deviation was 3. You'll notice not the exact same thing, and that's because this 1.67 had been rounded, and that's okay. It just means that the initial answer is not quite as precise as my second. But they're both close enough. They're both about 95%. 0.9522. So it is very typical for these cars to be able to make that stop. It would not be unusual, or sorry, it would be unusual if her car did not stop safely. So like I said, I don't usually standardize it first. I need to understand it could be done that way. I need to understand that that's what it's doing in case there's some multiple choice question that asks me in that format. But generally speaking, if I'm just trying to find a percentage that is going to be at least 290, I'm just going to jump to doing that. So I think we did example 5, part 1 in class where I turned it to the z-score first. So I don't know how much room you have, but I'm going to do it the alternate way. So I am just going to consider the specific normal distribution for Jordan Spieth. One of these years I'll look up this guy's name. So the mean of all of his distances is 304. The standard deviation was told to me to be 8. And again, I'm going to label that these are not z-scores. These are distances in yards. So specific to this scenario. So when I'm wanting the probability of at least 290, this is of this x value being greater than or equal to 290 yards. So this would be somewhere, I don't know, way over here. Definitely below the mean. I don't need to get super picky about how accurate it is, especially because my curve itself is a very poorly drawn curve. But this is what I'm finding. So I will go to my normal CDF. This time my lower will be 290 because I want it to be greater than. That's one of the perks about drawing it. Even if you don't understand what symbol is supposed to go here and you screw that up, as long as you understand the meaning of it at least and you know that it's this area, you should still be able to figure out that your lower boundary is 290 and your upper is just continuing on. Positive infinity would be nice, but 1000 is big enough to serve in its place. So the mean of 304 and the standard deviation of 8. So I'm not going to go to my calculator this time because I'm hoping you're kind of understanding what I should be typing in, and then I don't have to make you nauseous by shaking the camera all around. So I'm putting in 290, 1,304, and 8. And I'm getting about 0.9599. In class, we had gotten the exact same answer, and the reason it's not different is when I divided by an 8, when I standardized, it didn't make it so that the z-score was a non-terminating decimal. So there wasn't really any issue with the rounding this time. You can get the exact same score, but it is nice, not score, area, probability, percentage, 95.99%. But I just like not having to find the z-score unless you really need to / want to / feel like doing it. So the last one I'm going to do is on the next page, on page 25. Part B, we skipped it entirely. I'm only going to do this again without finding the z-score, especially because now if I'm wanting to go between 200 and 240, there would be 2 different z-scores that I would have to find, 2 different potentially rounded things, and it just isn't necessary. So I'm going to still, you can't skip this step, or at least you're not supposed to. I'm going to sketch my normal distribution. I'm going to throw my mean in the middle. For this one, the mean was 170. My standard deviation, that distance is supposed to be 30. And this is representing cholesterol level in milligrams per deciliter. Okay, so I'm finding the probability that my x value is between 200 and 240, which means I need to think about 200 is exactly 1 standard deviation away, so it would be here. 240 is a little over 2 standard deviations, but the to scaleness is not so much my concern. You just need to sketch it and shade. So I know that my lower, the last part to the left that I have shaded, would be the 200. The upper would be 240. Because these were not transformed to z-scores, I don't have a mean of 0. The mean of the x values is 170. The standard deviation of the distribution of x values was 30. Only put in 0 and 1 if you have standardized. So this would be, oh, I do already have my answer. When I typed this in before, I got 14.88%. So about 15% of 14-year-old boys have cholesterol between 200 and 240 milligrams per deciliter. So I just wanted to go over a few more examples. I know we did several in class, but I know we also don't have a ton of time to do all of what I would like. So I wanted to throw these in here just so you had more examples of skipping the step of standardizing first.